So in these problems, we're going to use algebra to simplify the trig expressions. So the ability to use algebra to manipulate trigonometric expressions is a key skill that you've got to have established to be successful with identities and establishing identities. Four basic algebraic techniques that are used here. So number one, rewrite a trig expression in terms of sine and cosine only. Okay, what do I mean here? Look, anything in trigonometry goes back to sines and cosines. Okay, so we learned with our identities before, say I had like a secant theta, I can make that in terms of sines and cosines. Okay, how? This is 1 over the cosine of theta. Okay, so if, you know, and then maybe if you had it multiplied by the tangent of theta, right? So that would be, okay, so that changes the problem just a little bit. So tangent of theta is sine theta over cosine theta. Okay, so that would be everything. So maybe it'd be sine theta over cosine squared theta. Okay, so that would be writing everything in terms of sine and cosine only. Okay, number two technique that might help you out is multiplying the numerator and denominator of a ratio by a quote well chosen 1. Okay, being a good mathematician is learning how to add 0 and multiply by 1. What do I mean by that? Okay, so multiplying by a clever 1, maybe, you know, if you think about it when you're rationalizing, like you have 1 over the square root of 5, to rationalize, I multiply by that clever 1 square root 5 over square root 5. And so when I multiply through, I get the square root of 5 in the numerator and 5 in the denominator. So some well-chosen 1, so a clever 1. So this is the idea here, okay? Number three, so writing sums of trig ratios as a single ratio. Okay, so what do I mean by that? Like if I go back to like my number analogy, like I have 1/2 plus 1/3. To write as a single ratio, I would need to get a common denominator. So I multiply both sides here by 3 over 3, a clever 1. And over here, 2 over 2, another clever 1. And so what does that get me? That gives me 3 over 6 plus 2 over 6. And now I can write this as one common single ratio. And so maybe now it's easier to simplify there. Okay, and so I'll show you what I mean here. I'm just doing an analogy with numbers to try to make it a little bit easier for you to understand what I'm talking about. The last algebraic technique, number 4, factoring. Factoring is useful. You know, maybe if we factor something, things cancel and go away. Like I have x squared minus 4 over x plus 2. Okay, so when I factor the numerator, I get x plus 2 times x minus 2 factored, and then I have an x plus 2 in the denominator. Well, guess what? Those x plus 2 factors cancel, and I simplify to x minus 2 as long as x plus 2 is not equal to 0, right? So as long as I avoid negative 2, this is a true statement. All right, so factoring can simplify, make something ugly look a lot slicker. Okay? So let's try this. So using algebraic techniques to simplify trig expressions. So I want to simplify cotangent theta over cosecant theta by rewriting each trigonometric function in terms of sine and cosine functions. Okay. Oh my goodness, this is actually kind of exciting. All right, so maybe the first lesson I really kind of starting to get a little jittery on. All right, I'm starting to get excited here, guys. Okay, so got to get my nerd hat off. Now, how do we do this? So we're gonna turn everything into sines and cosines. Okay, that first technique, that number one bullet. So cotangent theta is equal to cosine theta over sine theta, and cosecant theta is equal to 1 over sine theta. So cotangent theta over cosecant theta is equal to cosine theta divided by sine theta, all divided by 1 over sine theta. Okay? Now, remember, when we have a fraction divided by another fraction, we got to do KCF, keep, change, flip, right? Remember that? So, keep the numerator the same, cosine theta over sine theta, change division to multiplication, and flip, do the reciprocal, so that's sine theta over 1. Now, what do I see here? Sine theta and sine theta cancel, and so I'm just left with cosine theta. How about that? That was a lot easier, right? So no big deal there. Let's do another one. Let's take, let's show that cosine theta over 1 plus sine theta is equal to 1 minus sine theta over cosine theta by multiplying the numerator and denominator by 1 minus sine theta. Okay, so I'm going to multiply the numerator and denominator by 1 minus sine theta. So let's try this out. So cosine theta equals 1 plus sine theta. So I'm going to multiply the numerator and the denominator by 1 minus sine theta. Okay, and 1 minus sine theta. All right. So when I multiply this through, this, my friends, is a well-chosen 1. Okay, so this example here, a well-chosen 1. All right, that's what we mean there with a well-chosen 1. So this is going to be what? This is going to be distribute the cosine. I get cosine theta multiplied by 1. So this is, let's see. This is cosine theta sine theta, okay? Now, in the denominator, I have 1 times 1 is 1. 1 times negative sine is negative sine theta. Sine theta times 1 is positive sine theta. And sine theta times negative sine theta is negative sine squared theta, okay? What do I see about these two middle terms? They cancel. So I get cosine theta minus cosine theta sine theta over 1 minus sine squared theta. Now, I'm trying to make this look like this right here. I've got a 1 minus sine squared down here, but I have a cosine here. So what is going on? Well, hopefully you think, oh my goodness, this kind of makes me feel like a Pythagorean identity. What do we know that is equal to? Well, sine squared theta plus cosine squared theta equals 1. If I subtract sine squared theta from both sides, I get cosine squared theta equals 1 minus sine squared theta. So this becomes cosine theta minus cosine theta sine theta over cosine squared theta. Now we are almost home. What's the difference here? There's only one cosine here, but there's two here. But what do you see? What do you see that's going on here? Well, every one of these terms has a cosine theta in them, okay? So I can actually cancel out a cosine theta. If we didn't multiply this out, we would have had cosine theta n times 1 minus sine theta, right? But I was the knucklehead that distributed this out, and that's what happened there. So if you had not distributed out, maybe you could have saved yourself some time and saw, oh, one of those goes away, and we're left with 1 in the denominator. And therefore, we reach our desired result, 1 minus sine theta over cosine theta. Okay? So sometimes it's helpful to not just work this way to get to the answer, but maybe if you get stuck, start with your answer and try to meet up with somewhere in the middle. Okay? Sometimes it's easier to know how to do the problem if you're looking at the final answer. Okay. So the next problem is simplify 1 plus sine x over sine x plus cotangent x minus cosine x over cosine x by rewriting the expression as a single ratio. Now, how do you write this as a single ratio? Well, you've got to get a common denominator. Okay, so right now, we've got a denominator of sine x on one side and a denominator of cosine x on the other. So what is it missing? This one needs a cosine x, but if I put it in the denominator, I've got to put in the numerator a clever 1. If you multiply something by a clever 1, it doesn't change the problem. Okay? The only thing you could be doing is introducing extraneous solutions, but we're just doing an expression, so we don't have to worry about solutions. Okay? Oh, I'm sorry. I need to multiply to get the common denominator. So this needs a sine x. So my common denominator is going to be sine x cosine x. Okay? So up here, if I distribute, what do I have? I have cosine x plus sine x over cosine x sine x. And plus, now if I distribute here, I've got cotangent. Now cotangent is what? Cotangent is cosine x over sine x. Okay, so those are the same. Multiplied by sine x. And then minus cosine x sine x over cosine x sine x. Okay? So same denominator I can combine. So I have cosine x plus sine x. And then these sine x's cancel. So I have plus cosine x minus cosine x sine x. Okay? Oh wait, I didn't distribute this second cosine here. So this needs another cosine. Sorry about that, guys. All right, and then the denominator I have cosine x sine x. So what do I have? I got a positive one of these and a negative one of those, so those cancel. But then I have 2 cosine x's. So this is 2 cosine x over cosine x sine x. Well, what happens here? My cosine x's cancel, and I get what? I get 2 over sine x. 2 over sine x. Now, if you want to get funky, you could, and you could do 2 cosecant x, all right? But this is perfectly fine, all right? We were just asked to write it as a single ratio, all right? So this is a single ratio right there. All right, one more problem for showing you how to simplify trigonometric expressions. So I want you to simplify sine squared theta minus 1 over tangent theta sine theta minus tangent theta, okay, by factoring. Now, does anything factor here? Well, the denominator has a tangent here and a tangent here, so I can at least factor a tangent out. So this is sine squared theta minus 1 over tangent theta, and then multiplied by, well, what's left? I have a sine, and then I have just 1, right? So sine theta, and then minus 1. Okay. Now, the numerator factors, all right? So if you're having trouble seeing how this will factor, sometimes it helps to make a substitution. So you could say like u equals sine of theta, then sine squared theta is u squared, right? So if I have sine squared theta minus 1, that's u squared minus 1, which factors to u minus 1 times u plus 1, right? So what is that? That's sine theta minus 1, sine theta plus 1. So this sine squared minus 1 factors to sine theta minus 1 times sine theta plus 1. Divide by tangent theta, sine theta minus 1. And guess what? These two will cancel each other. And I see that I get sine theta plus 1 over the tangent of theta. How about that? So we just simplified via factoring. Okay? So in the next video, we're going to talk about establishing identities. So we're going to use the techniques, these 4 techniques here. Those 4 techniques are right here. Rewriting the trig expression in terms of sine and cosine only. Multiplying the numerator and the denominator by some clever one. Writing the sum of trig ratios as a single ratio, meaning get the common denominator, add or subtract them. And then last and probably very important is factoring. Okay, guys, if you're having trouble with factoring, you can always make your substitutions and go back to x's or use whatever you feel comfortable with factoring and then substitute back in at the end.